Okay, my dear students, so today we are going to start with the next part of the mass spectrometry. So yesterday we did some of the peaks relating to M and M plus 1. Okay, so today we are going to start with the next peaks. Uh, Again, we are having this graph in which along the y-axis you got the abundance, and along the x-axis you got the M over P values. So there are the different peaks present up here. Okay, so this peak is present at 27. This one is present at 46. This is present at 79. This is present at 91, and this is present at 93. So if you look at these peaks, my dear, these peaks are present at an unusual distance. Unusual distance means that there is no proper distance between the peaks. Okay, so it means these are the peaks of compound. So these are the compound peaks. Okay, so this is the first thing. These are the compound peaks. Now, if you got the compound peaks, I told you to have to look the last 1, 2, or 3 peaks which are very close together. So if you look, these peaks are very close together. So these peaks are actually the molecular ion peaks. Whereas these peaks, okay, these are called as the fragment peaks. Fragment peaks. Okay. So these are the molecular ion peaks, and these are the fragment peak mean I told you that a molecule break down into the smaller parts, so those are called as the fragments. So these are the fragment peaks. The molecular ion peaks, if you look at these peaks, okay, so the first peak that is always called as the M peak. Okay, now if you look the difference between the two peaks, this is 91 and this is 93. So these two peaks, they are present at a distance of 2. So this second peak, my dear, that is called as the M plus 2 peak. Okay, so you got M peak and you got M plus 2 peak. Okay, so if you got M and M plus 2 peaks, so it means you got one atom of halogen. One atom of halogen, and the word halogen means chlorine or bromine. Only these two elements of the halogen, they are present in your syllabus. So you got one atom of halogen present in the molecule if M and M plus 2 peaks are present. Now, how would we know by looking at these peaks whether these are the peaks of the chlorine or whether these are the peaks of the bromine? So it's very simple thing. Chlorine has got the two isotopes. The first one is 35 and the second one that is of 37. In the nature, the 35 one that is present almost 75%. If you take the 100 atoms of the chlorine, so 75% chance are that would be the 35 one. Whereas the 37 one that is 25%. Okay, so 75% and 25%. These peaks are of the chlorine. So if you divide the smaller number with both, so 25 is smaller, 75 is the larger number. So if you divide it with 25, okay, so you will get the answer 3:1. So it means if your M peak is 3 times, okay, this is 3 times M peak. And M plus 2 peak that is 1 time. Okay, this is the M plus 2 peak. Okay, so it means it means one atom of chlorine is present. Okay, if the height of the two peaks are 3:1. Okay, the M peak is 3 times and the M plus 2 peak, that is one time. So it means you got one atom of hydrogen in the compound. Okay. On the other hand, my dear, if you got the two bromine atoms like that, the two bromine atoms, they could be of 35 one, sorry, 79 and 81. So if you take 100 atoms of the bromine, okay, so 50% of the chance are these bromine atoms, they are of 79, and 50% chance that they are of 81. Okay, out of every 100 atoms, the 50 atoms they are of 79 one, and 50 atoms they are of 81. Okay, so if you divide it with smaller values, so both are smaller, so you can divide it with anything 50 divided by 50, so it would become 1:1. So if the height of the both peaks that is exactly same, this is m and this is m plus 2, so 1:1. So it means you got one atom of the bromine. One atom of bromine is present. Did you get it? Now, if we look up here, you got the two peaks m and m plus 2, they are of same height. So same height means these one bromine atom is present in this compound. Did you get it, guys?
Yes, sir.
Okay, guys. Again, we got a graph like that in which different peaks are present. I told you when the peaks they are present at an unusual distance. Okay, so it means these peaks are of the compound peaks. So these are the compound peaks. Now, what should you do, my dear? When you got the compound peaks, you have to look at the last peaks which are very close together. So if you look, these three peaks, they are very close together. So the first one that is called as the M peak. The second one, it got a difference of 2. So this is called as the M plus 2 peak, and 93 and 97. So this one got the difference of 4. So this is M plus 4 peak. So if you got M, M plus 2 and M plus 4 peak in a compound, so it means the two atoms of halogens, chlorine or bromine are present. Did you get it?
Yes, sir.
Now, how do you know by looking at the heights of these peaks whether these are the two chlorine atoms, whether these are the two bromine atoms, or whether it contains one chlorine and one bromine atom? Okay. Now, if you got the two chlorine atoms, okay, the two chlorine atoms, so Cl2 positive. So, what could be the height of the peaks? Okay, to find out the height of the peak, you know that chlorine got the two isotopes, the 35 one and 37 one. So these are the two isotopes, and the existence of this one is 3, and the existence of this one is 1, 3:1. That is the ratio in between those two isotopes. So if you got the two chlorine atom, guys, so two chlorine atom mean that both atoms could be of 35 one. Okay. The second option, one atom. So 35 one mean 35 is having the ratio 3, and this one is also having the ratio 3. So 3 3 is a 9. Okay. In the second option, you got Cl35 and Cl37. Okay. So 35 one has the ratio 3, 37 one has the ratio 1. So 3 into 1 is 3. Okay. The next one that is Cl37 and this is Cl35. Okay, because two chances are there. The first one atom is 35, the second one is 37. Up here, the first one is 37 and this is 35. So this is 1 into 3, that is also 3. Now, if you count their mass number, that is 72. The mass number of this one is 70. So both of them, they are having the same mass, 72. So you should add them. You should add them 3 and 3, that would become 6. Okay? अब पुरानी चीज हम लोग कर भी चुके हैं, तो मुझे चलिए आता हूँ, अब करेंगे. Okay, guys, so this is 6, and then we got the next thing, that is the 2 chlorine atom with 37 and 37. So this is 1 into 1, that is 1. Okay. So now if you look, you got the 3 peaks, the M peak, that would be 9, and the M plus 2 peak, that would be of the height 6, and M plus 4 peak, that would be of the height 1. So this is M peak, this is M plus 2 peak, and this is M plus 4 peak. Okay. So if the peaks are present in 9:6:1, so it means the 2 chlorine atoms, they are present. Did you get it, guys?
Yes, sir.
So the ratio of the abundance, उनके abundance है. Okay, now if you got the 2 bromine atoms, guys, the 2 bromine atoms, they could be, the same method would be used. You know that bromine has got the 2 isotopes, 79(1) and 81, and the abundance of this one is 1, and abundance of this one is 1. So 1:1, that is the ratio of their abundance. Now, if you got the 2 bromine atoms, and the first one is 79, the second one is 79. So 79(1) is 1, and 79, that is also 1. So 1 into 1 is 1. Okay, and then you got bromine 79, and this is the bromine which is 81. So this is 1 into 1, that is 1 as well. So if you take the bromine 81 and this one bromine 79, so this is 1 into 1, 1. Now, if you just add these values, you will get the same mass number. This is 79 and 79. What it would be? 158. Okay, this is 158 and this is 160. Okay, so they are having the same mass number, so you should add them. 1 plus 1, that will become 2. Okay, and just like that, the 2 bromine atoms with 81 and 81. So this is, my dear, 162 mass number. So this is 1 into 1, 1. Okay, so you got the ratio 1:2:1. The first peak is 1. The M plus 2 peak is it's double, and then M plus 4 peak, that is 1. Okay, this is M plus 2, and this is M plus 4. So if the peaks are present in a ratio of 1:2:1, so it means 2 atoms of bromine are present. Did you get it, guys? So you should know how to calculate these ratios in the paper. 3 or 4 times he has asked this question. Okay. Now the last thing, my dear, if you got 1 atom of the chlorine and 1 atom of the bromine, so these are the 2 different atoms. So in that case, you just have to memorize the ratio of the height. That is 3:4:1. Okay, the first peak is 3. The second one is of 4. Okay, and then 1. So this is the M peak. This is the M plus 2 peak, and this one, that is M plus 4 peak. Okay, so 3:4:1. So if 1 chlorine and 1 bromine atom is present, no calculation is required for that. You just have to memorize this one. Okay, did you get it, guys?
Yes, sir.
Yes.
Okay, my dear students, now what we are going to do, we are going to discuss some of the past paper question. I'm sending you a worksheet on the group. Okay, guys, I'm going to share a screen with you. Okay, and then we will start with some of the questions relating to the mass spectrometry. Okay, Now using this one, you are given the values of M and M plus 1 peaks. Okay, by using this one, you can find out the number of carbons in a compound. I told you about it. So can you find out the number of carbons? Okay, by using these ratios. So M and M plus 1 ratios are given up here. So I told you by using the M and M plus 1 ratio yesterday, you can find out the number of carbons from a compound. So number of carbons, that is equal to M plus 1 into 100 divided by M into 1.1. I told you this formula yesterday. Okay, so now we are putting the values up here. M plus 1, that is 2, and M, that is 25. I'm going to tell you an easiest method. M plus 1, that is always small. Okay, the small value would be of M plus 1. Okay, so 2 times 100 divided by the M, that is 25 times 1.1. So if you solve it up, guys, let me know what the answer you got.
7.27.
How much? 7?
0.27.
7.27. So you should make it equal to whole number. So 7. So it means this compound contains 7 carbons. So the value of X for this one, that is 7. Did you get it? Question number 2, just solve it up. We have done it right now. We do it by yourself again. In a given pesticide contain 2 chlorine atoms per molecule, deduce the relative heights of M and M plus 2 and M plus 4p. This is a 3-mark question. So you should find out on the whiteboard. I have done it. Have a look up here. Okay. So this whole calculation you have to show. Okay. सर इसकी evidence याद भी होनी चाहिए और कैलकुलेट भी करनी आनी चाहिए, बताया तो है. If you got the 2 chlorine atoms, okay, 35 and 35 one, so the abundance is 3 into 3. So that would become 9. So 35, 37 or 37, 35. So both are having the same mass. So their abundance is 3 into 1 or 1 into 3. That would be 3, 3. Because they have got the same mass number, you should add it. So it would become 6. And then 1 into 1, 37 and 37. So it would be 1.
Sir, 35 isotope is 75% present.
Yeah,
ये
exactly.
यार इससे तो
हाँ, तो ये 3:1 तो तुम्हें याद होना चाहिए. वो 75% और 25% 3:1. ये रेशो याद.
कितने एलिमेंट्स सर याद होने चाहिए?
ये बताया तो है, सिर्फ ये क्लोरीन, ब्रोमीन और एक क्लोरीन और एक ब्रोमीन.
Okay.
Guys, you know how to solve this question? This is done on the whiteboard in front of you.
So,
Question number 4, please. Question number 4, I'm going to show you the whole question. Okay, this is the whole question. Question number 4. So start doing this question by opening up your own worksheet. So you should try, everyone should try. I'm going to give you 3 or 4 minutes for that. Or let me do it for you. So if you look up here, my dear students, he's gonna say when reacted with a small quantity of SiCl4. So Si is attached with the 4 chlorine atoms like that. Okay. Water, it reacts with the water. So water is HOH. And he's saying this compound is being formed. And he has given the different fragments. The last peak, that is of the molecular ion peak. This is the molecular ion peak. Okay. So the molecular ion peak is only one. He had not given you more molecular ion peaks. Okay. So now these are the fragments. Now using these fragments, we can find out the structure and the molecular formula of this compound. First of all, let's find out the total MR of this SiCl4, and he's gonna say you that for chlorine you should use this isotope 35 one, and for silicon you should use 28 one. So if you find out the MR of SiCl4, let me know what the answer is.
168.
168. So 168, that is the MR of SiCl4. Okay. So when the reaction occurred, one of the chlorine atom that will come out. Okay. So if you minus 35, so what it would become? 133. So if you see, the first fragment is 133. So it means SiCl3 positive, that is of 133. Okay, all the fragments and the molecule, it got the positive charge in mass spectrometry. I told you yesterday. Okay, now if you minus this 149 from 133, it would be 16. So 16 would mean oxygen is added. So SiCl3O positive. So that is 149. Now if you subtract 247 from 149, so that would be 98. The 98 mean one silicon atom and two chlorine atom, because 35 and 35 70, and one silicon atom, that would be 28. So it would become Si2Cl5O positive, that is 247. And 263 minus 247, that is 16. So one oxygen is added up here. Si2Cl5O2 positive, that is 263. Now, if you subtract 396 from 263, it would be 133. So 133 again, SiCl3 positive, so that would be added in it. Si3Cl8O2 positive, that would be 396. So it means your molecular formula of the compound, that is Si3Cl8 and O2. So this is the molecular formula. Now, if you want to draw the structural formula, so firstly you got SiCl3, so draw Si with 3 chlorine like that, and then one oxygen is attached, attach one oxygen, and then one Si and two Cl attached, so one Si and two Cl attached, and then one more oxygen, and then one Si and 3 chlorine are attached, so Si and 3 chlorine. So this is the structural formula of this compound. Did you get it?
Yes, sir.
Now you open this standard.
ये वही तो बता रहा हूँ, तुम्हारे करके दिखाया.
Yes.
If you want to take the screenshot, you can take it for your future use, because this was considered to be one of the hardest question at that time. Most of the students, they were unable to do it.